Hey there, everybody. Welcome back. This is our ABCDEF is 6, our 7th video for 14.2. I did them all really short. This is our last example. It's an ugly problem. We are going to find the volume of the wedge cut from the cylinder, 4x squared plus y squared equals 9. And the cylinder, or the wedge that's cut has a boundary of z equals 0 on bottom and z equals y plus 3 along the top. So I drew the ellipse first. 4x squared plus y squared equals 9. Divide by 9 to get the right side equal to 1. We would have a 4/9 in front of the x squared, but when you rewrite it like this with everything on bottom, it makes it easier to see what your boundaries are for the ellipse. Just take the square root of the bases. Square root of 9/4 is 3/2, so we're going negative 3/2 or 1.5 either direction along x. Square root of 9 is 3, so we go up 3 and down 3. That's our ellipse. So the ellipse is like this in the xy plane. The cylinder keeps going all the way up and down. It didn't have any constraints on z, so it goes all the way up and down. We're going to bound it below by z equals 0. And it starts at z equals 3. When y equals 0, oh, that's not even the lowest. If I plug in y equals negative 3, it should actually come all the way down like this. I drew it wrong. It should be more like that. When y equals negative 3, z equals 0 in the y plus 3 thing. So it's more like that. And we got some wedge like that. Okay. But it's clear our upper surface is this z equals y plus 3 line. So let's just look at how we can integrate this. We need to know things in terms of the xy plane. I got y squared equals 9 minus, solve this for y. I got y squared equals 9 minus 4x squared. We got the absolute value of y equals the square root of 9 minus 4x squared. That's where we get our plus or minus, which we have here. If we do that for y, we've got x is going from negative 3/2 to 3/2. I don't think it gets any easier going the other direction, so let's just run with this one. Okay. We got y plus 3, which was easy to integrate. 1/2 y squared plus 3y. We plug in our stuff, we get that. We clean it up. And we get 6 times square root of 9 minus 4x squared dx. You can go through the math and verify that if you'd like. Which I wrote as 3 squared minus 2x squared. I looked up the following integrals. We got the square, or the integral of the square root of a squared minus u squared du. I don't have the inverse that memorized. There are tables for it. But when it's in this format, a squared minus u squared on the inside, we get 1/2 u square root of a squared minus u squared plus 1/2 a squared sine inverse of u over a. So if we match up what we got here, a squared is 3 squared, so a equals 3. U squared is the quantity 2x squared, so u equals 2x. I did a u sub to rewrite it so it looks like the a squared minus u squared. U equals 2x, so du equals 2 dx. I changed my boundary conditions to match u. And I rewrite my integral as such. The 6 turns into a 3 because of this 1/2. And then I've got the new boundary condition from negative 3 to 3. Square root of 3 squared minus u squared. Now I can mimic this formula, this answer right over here, which I do. And then we're evaluating from u equals 3 to u equals negative 3. So this line right here came from there. That's from a table of integrals. After that, it's all some legwork. Plug in 3 and negative 3. You can see some stuff zeros. 9 minus 9 is 0, so that goes away. That goes away. And I've got 9 times 3 over 2 on both of them. I can factor the 9 out. I got 27 over 2 on the outside. This is sine inverse of 1. This is sine inverse of -1. Where does sine inverse equal, or where does sine equal 1? It equals to that pi over 2. Where does sine inverse or sine equal -1? It equals to that negative pi over 2. So those are what those values are. We can see we get 27 pi over 2 as our answer. So it's ugly, but it's doable. And that'll be it for this section. There may be other ways, better ways to do this. This is a rough region to do. Maybe we could do better in polar coordinates or something like that. That's next section, 14.3. Peace.